Mayong adlaw o mayong adlaw sa tanan. Welcome to the second semester of school year 2020 to 2021 and welcome to CPRT 42 with the descriptive title of Approaches and Practices in Pest Management focused on weed science. So I am Junri Anthony M. Remolio from the Department of Agronomy and Plant Breeding. So I will be teaching you the basic concepts on herbicide computation because this is vital and necessary in learning weed science. We are largely be dealing with herbicides. So give me a minute to show you my slides. Okay. So again, I'll be teaching you sample problems on herbicide computation. You need to learn these basic competency skills in solving how to solving herbicide subject to application. Okay, before that, we need to define important terminologies. So first, herbicide. This is a chemical used to kill or inhibit the growth of plants, especially weeds. Comes from two root words. Herba means plant and caedere, which means to kill. And then calibration is the process of measuring and adjusting the amount of pesticide your equipment will apply over a target area. And it is the critical step or the critical first step in making certain that your equipment is applying pesticide uniformly and at the correct rate. And it is important for us that whatever amount we will apply herbicides on our crops in order to control the weeds, we need to apply it in judicious amounts. And that is why herbicide calculation existed. Why is calibration important? First, in order to obtain the performance of a pesticide as specified on the product label, and then to be able to repeat successful procedures and minimize expenses. Because as we all know, herbicides are costly, especially in the case of farmers. And then we need to diagnose problems with failure in product performance or crop injury. With the presence of calibration, then we could easily track what are those failures, especially if there is an existing over application or under application, things like that. And then to be able to document legal doses applied when using restricted use pesticides. Most important under current and increasing scrutiny by the state regulatory agencies. There are laws that are governing, especially as far as the application of our herbicides is concerned. And then, in this slide, we need to remember the basic formulas which will be useful in computing for our herbicide. So first, the quantity of the herbicide, which is equal to the recommended rate and the percent active ingredient. And then the second one, quantity of formulated product required, which is equal to the recommended rate of active ingredient divided by percent active ingredient in the formulated product. And then the tank loads in hectare, which can be obtained by the volume of delivery divided by the sprayer capacity. And we need to remember that the capacity of a typical knapsack sprayer is 16 liters. Though there are some varieties of knapsack sprayer which contains greater than 16 liters, but for instructional purposes, then we will use 16 liters. So to compute for the quantity of the herbicide needed, using those formulas that I've shown earlier, then we need to compute for the quantity of the herbicide, given that the recommended rate is 1 kilogram and the active ingredient is 4 grams per liter. So, in order to facilitate the computation, we need to convert first the 1 kilogram into 1,000 grams. So, I hope you already know that in a kilogram, there are 1,000 grams. So, you divide it by 400 grams per liter, which is the recommended active ingredient, then it will result to 2.5 liters per hectare. And observe that in the solutions, we cancel the unit gram, especially in dividing the two values. So we need to cancel it, and this will give us an idea what is the unit or what are the particular units to be used in computing such values. So let's proceed to the problem set number 1. And I'll be giving you 4 sets of problems for this presentation. So first, EC is a liquid herbicide which contains 400 gram per liter of active ingredient. The recommended rate for a hectare of land is 1.2 kilogram of active ingredient. If the application volume is 200 liters per hectare, we need to calculate for the following. First, the quantity of EC herbicide needed per hectare. And the second one, the volume of delivery expressed as the number of tank loads per hectare. And then the number of tablespoons of EC herbicide to be replaced per knapsack sprayer tank, and the area covered by 1 tank load of sprayer. So according to the problem, the given values are the 400 gram per liter of active ingredient in a liquid herbicide EC, and then the recommended rate of 1.2 of kilograms active ingredient, and then the application volume of 200 liters per hectare. And these values are useful in computing such values, and then the number of teaspoons, things like that. So, in computing for the quantity of EC herbicide needed per hectare, then we need to use this formula, the quantity of formulated product required per hectare, which can be obtained by dividing the recommended amount of active ingredient by the percent active ingredient in the formulated product. Since based on the problem, 400 grams per liter is given, we need to convert this into kilogram in order for us to easily compute for such value. So we need to convert 400 gram into 1,000 to 1 kilogram. So in order to convert, then we multiply 400 kilogram, 400 gram based on the slide. You multiply it by 1,000 gram divided by 1 kilogram, because in a kilogram there are 1,000 grams, which will result to 0.4 kilogram liter. And we need to cancel the grams unit as we facilitate multiplication. So cancel the gram from 400 and then the 1,000, and what remains are the kilogram and the liter. That's why I put kilogram liter beside 0.04. And after which, since the percent AI is already available, then we can now compute for the quantity of the formulated product required. So based on the given 1.2 kilogram per hectare divided by 0.4 kilogram liter, then we could come up with a result of 3 liters per hectare. And observe the solution. We cancel the kilogram units, and what remains are the liters per hectare. And if you go back to the earlier slide that I shown, then in order to obtain for the quantity of the food of the formulated products required, then we must remember that we need to use liters per hectare as the unit. Okay? And then the second one, we need to compute for the volume of delivery as expressed as number of tank loads per hectare. So this is the formula. We need to divide the volume of delivery and the sprayer capacity. So the 200 liter per hectare volume delivery was given. So we just divide it by the sprayer capacity, which I mentioned earlier is 16 liters. And it will result to 12.5 tank loads per hectare. So based on the solution, we canceled the units liter. So what remains is the hectare. Okay? And letter C, the number of tablespoons of easy herbicide to be replaced per knapsack sprayer tank. And in order to obtain for the number of tablespoons, then we need to divide the quantity of herbicide which we have computed earlier divided by the number of tank loads per hectare. So 3 liters divided by 12.5 tank loads per hectare equals 0.24 liter. However, we need to convert this first. We need to convert this into milliliter. So, in order to obtain such value, we multiply 0.24 liter by 1000 ml, which and then divided by 1 liter, and it will result to 240 ml. And then after which we convert 240 ml into tablespoon unit. So we need to remember that in 1 tablespoon it contains 10 milliliters. So in order to convert it, then we multiply 240 ml by 1 tablespoon divided by 10 ml. And it will result to 24 tablespoons per tank load. Got it? Okay. And then the last one, we need to compute the area covered by 1 tank load of sprayer. And in order to obtain such, then we need to divide the area by the number of tank loads in hectare. So we need to convert the area or express it in square meters. So you need to remember that in 1 hectare, there are 10,000 square meters. And that 10,000 square meters we will be used in computing the area. So 10,000 square meters divided by 12.5 tank loads result to 800 square meters per tank load. Okay, so let's proceed to problem set number 2. Find the volume of delivery in tank loads per hectare given that the amount of volume delivered in a 20 square meter is 400 mil or milliliter after calibration. So, in order to compute for the values needed, then we need to compute first for the volume of delivery. So, based on the problem, the given values are the amount of volume delivered after calibration, which is 400 milliliter with respect to the area, which is 20 square meters. Okay, so in order to compute, then we divide 400 ml by the area, 20 meters squared. So it will result to 20. So After which, then we will multiply 20 by 1 liter divided by 1,000 milliliter in order to come up with amount in unit liters. So times 1 liter divided by 1,000 equals 0.02. And after which, we multiply it by 10,000 square meters, which is the equivalent value for a hectare basis area. So times 10,000, which results to 200 liters per hectare. So observe what are those units that have been canceled. Okay, we canceled first the milliliter units when we obtain the value of the volume of delivery in liters. And then after obtaining the volume of delivery with the right unit, which is the liters per hectare, then we we multiplied it by 10,000, and then we canceled the square meters units. So what remains are the liters and the hectares. And based on the slides that I showed earlier, it conforms to the right unit for the volume of delivery, which is liters per hectare. So you need to remember it in order to guide you in coming up with the right answer. After which, we can now compute for the number of tank loads per hectare. So we simply divide 200 liters per hectare by 16 liters. And it will result to 12.5 tank loads per hectare. Okay. The next problem. So this is in connection with the given data in problem set 2. So we will use the same given values in computing for the problem set number 3. But in this case, the recommended rate of the herbicide is 0.5 liters per hectare. So how many milliliters of the herbicide should be added per tank load of knapsack sprayer? So simply we just compute for the volume of delivery. So based on the problem, it was given that the recommended rate is 0.5 liters per hectare. So we just divide 0.5 liters per hectare by 12.5 tank loads per hectare, which we computed earlier. And it will result to 0.04 liters. However, we need to convert it first into milliliters. So we multiply it by 1,000 ml divided by 1 liter. So we cancel the liter units. And it will result to 40 ml herbicide per tank load. So that would be the milliliters of herbicide that should be added per tank load of knapsack sprayer. So let's proceed to problem number 4. HERBAX containing 30% AI per liter has a recommended rate of 10 tablespoons per knapsack sprayer load. If the volume of delivery is 160 liters per hectare, then what is the equivalent volume of delivery in number of tank loads per hectare? And then we need to compute for the volume of HERBAX that needs to be applied per hectare in milliliters. And then, based on the answer in letter B, what would be the equivalent amount of active ingredient to be applied? So first, let's compute for the equivalent volume of delivery in the number of tank loads per hectare. So simply we use this formula, the tank loads per hectare, which can be obtained by dividing the volume of delivery by the sprayer capacity. Okay, so based on the given, the volume of delivery is 160 liters per hectare. So we divide it by the standardized knapsack sprayer capacity of 16 liters. So 160 divided by 16 equals 10 tank loads per hectare. Okay? And then, what would be the volume in milliliters of HERBAX that needs to be applied per hectare? So using those uh, given values in the problem, then it will be useful in computing for item letter B. So it was stated that the recommended rate, the HERBAX containing 30% active ingredients per liter has a recommended rate of 10 tablespoons per knapsack sprayer load. So that only amounts to one sprayer load. However, we need to obtain for the volume of ml that needs to be applied per hectare. So based on the answer that we computed in letter A, we already got the volume of delivery in the number of tank loads per hectare. So we need, using these values and the given values in the problem number 4, then we are to compute for the volume in milliliters. So first, we need to convert first the recommended rate of 10 tablespoons into milliliter. So we all know that in 1 tablespoon, there are 10 ml. No? So 10 times 10 tablespoon times 10 ml is equal to 100 ml tank load. So we cancel the tablespoons in order to uh, obtain the value in milliliters. So the 100 ml tank load will then be multiplied by the 10 tank loads, which is the equivalent volume of delivery in the number of tank loads per hectare. So 100 ml times 10 tank loads divided by 1 hectare. Just to present our solutions in order, then we could come up with a result of 1,000 ml per hectare. Okay? And for letter C, based on the answer in letter B, which is 1,000 ml per hectare, what is the equivalent amount of active ingredient to be applied? So, in order to obtain such, then we simply just multiply 1,000 ml rather by 30% AI, which was reflected in one of the given values in our problem, which results to 300 ml. So that's the answer. In conclusion, calibrating your equipment will save you money by not wasting pesticides from over-application and time by preventing need for reapplication from under-application. And over-applying pesticides also can result in the excess residues on in plants, soil, and surface or groundwater. And we must remember that exceeding the label rate of application is a violation of the law because as I mentioned earlier, there are laws governing such application in our herbicides because as we all know, our herbicides are harmful chemicals. It contains hazardous effect when it is mismanaged or misused. Especially if in an event that in your area where you did the application, there are children or minors who have little knowledge about the chemical, then it might harm them, not just our crop plots. And whenever possible, calibration should be done using water or another non-toxic carrier and wear the appropriate protective equipment whenever using a pesticide. So of course, In your case, no, since it's pandemic, so you cannot be able to do hands-on experience in using the knapsack sprayer. So I hope you will just put this in mind and heart, all these things, because this will be useful in the higher crop prot subjects. And remember to always read and follow all the pesticide label information. I believe that you have already learned this during your exercise number 1 on herbicide label. So that would be all for my presentation, and I hope you have learned a lot. And if you have questions, clarifications, then feel free to consult your respective CPRT 42 with science professor or instructor. So thank you very much for listening and have a great day.